Okay, so welcome to the second NAudio live stream Q&A. I'm hoping that this time I've managed to set things up a little bit better than I did last time. What I've done on the monitor I'm capturing, I've reduced the resolution of it, and I've also upped the resolution I'm streaming at to a higher resolution. So hopefully this is going to work a lot better. And I'm also using this headset microphone, which is going to be a little bit further away from the keyboard, so hopefully it won't pick up as much keyboard noise. I do have a better microphone that I could pull out over here. This is my trusty Sennheiser E835, which I do pretty much all of my Pluralsight courses through. It's only a cheap microphone, but it's ideal for voice work, but it kind of gets in my way of seeing the screen when I've got this in front of me, so I prefer for this just to use a regular headset mic. So as before, I've picked out a few recent NAudio questions that I've been sent or that have appeared on Stack Overflow. There was quite a few on Stack Overflow this week. 3 came in today, so I'll try and get through a few of these, and I'll also try and keep it to about 20 minutes again. And if you're watching live, feel free to write something in the chat, a question, or just say hello. Okay, so the first question on Stack Overflow is this one here from Kinetic, and I have to convert an SPX audio file in OGG format to MP3 file. I've tried a couple of things so far, nothing is working. And this person is using the lame MP3 file writer. So this is a library that's not actually part of NAudio. Someone called Corey created this as a wrapper for lame. So this kind of integrates with NAudio. Also, NAudio doesn't have any built-in OGG decoding, so really this isn't an NAudio question at all. But the person's written some code that's trying to decode OGG and then trying to encode MP3, and it's not working. And so what I usually recommend in this circumstance is to see the conversion you're making as a two-part conversion. So when you are converting from one audio format to another, particularly one compressed audio format, you have to go to PCM in the middle. So first decompress from OGG to PCM and then encode from PCM to MP3. So that's really all I'm going to recommend in the answer. So conversions like these, this needs to be done in 2 stages. First, decode from OGG to PCM, then encode from PCM to WAV. So if there are problems, a great way to debug is to create a WAV file from the decoded OGG first of all, and that allows you to listen to the decoded audio and check it is all okay. Then you can tackle the second stage of encoding to MP3. You can use the NAudio WAV file writer class to create your WAV file. So it's not really given him a full code answer to this question, but often the best way to answer this sort of question, I find, is just to give people a pointer in the right direction. So the next question that I'm going to look at is play 32-bit audio with NAudio and ASIO. So another ASIO question. So I'm trying to play a 32-bit byte array via NAudio and ASIO, but I can't get it running. The output signal is distorted. Okay, and the same converting method works fine with 32-bit for NAudio and Wasapi. Okay, and so they're showing a sample of how they're converting, which is calculating some kind of amplitude in some way, and yeah, I'm not entirely sure what they're doing to create the audio in the first place, but it looks like they're making a 32-bit PCM audio. Now, one of the things about PCM audio is that you can have various different bit depths. 8 bits is really not very great quality. There's just not enough signal to noise ratio there. 16-bit is what you have in CDs and is perfectly adequate for most uses. Sometimes in high-end recording situations, you'll see 24-bit audio, which just gives even more headroom to allow you to record at a good level without distorting. But really, most digital to analog converters don't have a resolution of more than about 20 bits. I go into this in one of my Pluralsight courses on digital audio fundamentals. Basically, 24 bits is more than you could possibly ever need. So why do you have 32 bits? Well, the main reason for 32-bit PCM is simply that computers deal more easily with 32 bits. Usually what you've got is a 24-bit sample put into 32 bits, and so it could just be a simple case of the ASIO driver is expecting it to be aligned in a certain way. So I'm going to probably just suggest to this person that they need to have a look at the different ASIO modes. Let's get the NAudio source code up here and bring up the ASIO class, and somewhere in here, if I can remember where it is, the whole ASIO component was contributed by Alexander Mutel, who made Sharp DX. So it's not my own code, but it's worked really well. Here we are, the ASIO sample types. And so there's all kinds of sample types, including int32 MSB, presumably most significant bit or byte first. But then you'll see down here there's int24 LSB, int32 LSB, int32 LSB24, so this is 32-bit with 24-bit alignment. It may be that this particular ASIO card is expecting you to use one of these. So what I'm going to suggest, where's my audio, my web browser, are a number of different ASIO sample types available when using 32-bit audio, because often it is just 24 or 20-bit audio placed somewhere in a 32-bit integer. So I suspect that maybe the wrong sample type is being used, or could it be that you are actually producing IEEE floating point samples which are also 32-bit and is what Zappi likes to use. So I'll just suggest that and see if it points them in the right direction. Again, without seeing more of the code of how they've implemented this wavetone class, it's very hard to know what the issue might be. NAudio does try to pick the right ASIO sample type where possible, but it could be that we've picked the wrong one for this particular sound card. I have needed to make various bug fixes to the ASIO for different sound cards, and sometimes I don't have that sound card, so I'm reliant on people telling me about the issues that they're running into. Right, let's go on to the next question. How to use handling multi-channel audio with NAudio. I'm not sure that quite makes sense, but the goal is to get real-time actual peak value from several audio files playable. Is this not the question from... I'm sure I answered this almost exact same question yesterday. Several audio files playable simultaneously. Yeah, I think this person has asked the same question several times. I've seen it on the Coplex forums, I've seen another version of it, I'm sure on Stack Overflow, maybe even on GitHub as well. So I'm not going to answer this one again. You can see in video 1 the answer I just gave to that question. Right, let's just check this isn't another question by the same person. No, this is another question about playing audio files simultaneously though. How to play 2 audio files simultaneously with real-time size value with NAudio. First time working with NAudio, so need your help. Same way as I got here, real-time from default audio source, how can I get 2 audio WAV or MP3 files to both play simultaneously with real-time value? Just the same way, but to get current peak size from each. Okay, this is a very vague question. I'm surprised it's got 2 upvotes. It's probably 5 stars. Probably this person's colleagues working on the same team hoping that this question will get some attention. And so the code that we're seeing here is, right, so I'll just say to play multiple files simultaneously, which is what I think you are asking to do. You should use an audio file reader. You should create an audio file reader for each of the input files, and then connect each of those as inputs to a mixing sample provider. And I think I'm going to sneeze, so just okay. Connect each of those as input provider, then initialize your output audio device with the mixing sample provider. And I should probably write a blog article with just a very simple example of this, because there's so many questions about this. One very unfortunate thing about the internet is that old answers to questions from years ago keep cropping up. So here you can see this code comes from a really old Stack Overflow answer that is utterly out of date, and this person has obviously found that answer and copied the code. I just see this come up again and again, and I've even commented on that Stack Overflow answer and saying please don't do this. You don't need to use wave channel 32, you don't need to use block align reduction stream and wave conversion stream and all of that. This is all probably completely redundant to what this person is trying to do, and I'm trying to push people in the direction of using iSample Provider in NAudio, which is just dealing with IEEE floating point samples and is much simpler. So Audio File Reader implements iSample Provider, and Mixing Sample Provider can mix them together, and you can now in NAudio just pass an iSample Provider directly to your wave out device. So it's much simpler to set it up like that. So I'll recommend that, and I imagine I'll get a response saying please show me the code, but we'll do that for now. Okay, so this is an interesting question. Hi Polyphony. Hi there, is there a way to make NAudio able to play or loop up to 8,000 sample streams simultaneously, or is C# just too slow? I need this to create a virtual pipe organ and would like to stick to open source content. Okay, what is my answer to this? My answer is I think you would struggle to do that. 8,000 sample streams. It depends how much CPU usage is needed to create the audio. Is it some kind of algorithm creating the audio, or is it pre-recorded sounds, in which case it might be less taxing? Is C# just too slow? C# isn't particularly slow. It performs pretty well for the most part. You have to be careful with how you write your C# code, particularly not to create too much work for the garbage collector, which can cause your execution to temporarily stop while garbage collection happens. C# is also sometimes doing extra security checks, like checking you've not gone out of bounds of an array for you, which makes it a little bit slower. I suspect that 8,000 is pushing the limits, but the answer really is for this person to just try it and see. So I'll say C# is quite fast, although is not going to be as fast as an audio engine written in optimized C++. The main issues here are how much work is required to generate the audio for the 8,000 streams. Is it pre-calculated or calculated on the fly? Also, do you need low latency? So the higher the latency, the more chance you have of being able to do a lot of work before passing a buffer of audio to the sound cards. If you've got very low latency, then a garbage connect can really screw things up for you. So low latency can be a challenge due to garbage collection causing glitches in the audio. I recommend you try and see by mixing together a bunch of sounds, say using the signal generator class, and mixing them with Mixing Sample Provider. You'll soon get an idea of what's possible on your hardware. Just be careful of your ears. and making loud noises. Yeah, one of the troubles if you're doing any kind of algorithmic sound generation is that you can really make some horrendous noises that are very loud and could damage your speakers and your ears. So I always recommend to people start with the volume very low if you're doing any sound generation, and probably don't wear headphones, or especially little in-ear things. Or if you're using headphones, just have them around your neck like this, and so you can start playing the sound, and if it sounds like it's making a terrible noise, you can switch it off before you damage your ears, because they are not easy to fix once you've broken them. Right, so I'll reply like that, and hopefully this will give this person a bit of a pointer in the right direction. Okay, just 2 more questions. This one, NAudio exception, this one I have actually already responded to, but I wanted to feature it on this Q&A session. I'm trying to convert a WAV file to an MP3 file, and it's saying no driver. On some of the WAVs, I'm getting no driver calling ACM format suggest when I'm trying to convert. And I want to see if anyone's had experience. Now, ACM format suggest, this is basically when you open a WAV file, it's got a WAV format, which describes the codec and the encoding properties that have been used in that WAV format. And if you want to convert that to another WAV format, then the old ACM API, which is kind of obsolete now really, or it's been retired in favour of Media Foundation codecs. But the old ACM codec system has been part of Windows for ages, and NAudio uses it for the MP3 file reader class. And you basically just ask ACM, have you got anything that can convert from this format to that format? And if ACM hasn't got codec, it'll just say ACM format suggest error. I can't come up with a codec that can do that particular conversion. So really, when I see questions like this, and this comes up quite common, I have to ask the person, well, what is the WAV format that you're trying to decode? Because without seeing that, it could be something like G723 or MuLaw, or unlikely to be MuLaw because that comes with pretty much every version of Windows, but it could be something a little bit unusual, and without seeing the WAV format, I can't really help Dan any further. So I'm just going to leave it with that comment. It doesn't look like Dan has got back to me in the last week on that. And so let's answer the last question that I have for today. From Legacy Wolf. Hello, I'd like to know how to get or calculate the bitrate in kilobits per second of an MP3 media file. Well, MP3 file consists basically just of a load of MP3 frames, and each one of those can have its own bitrate. In a constant bitrate MP3 file, every one of those frames will have the same bitrate, but in a variable bitrate file, everyone could have a different bitrate. And so it's quite a hard question to answer really. If you've got access to the whole file, you can just calculate it yourself, because you can work out the total duration of the file, and NAudio's MP3 file reader would do that, and so you can divide the number of bytes in the file by number of kilobits in the file by the number of seconds, and you get kilobits per second calculated that way. Or if you've detected this looks like it's a constant bitrate file, because all of the MP3 frames themselves have got the same bitrate, then you can do it like that. If you're streaming the MP3 file, then you've got a problem, because you don't know if it's CBR yet, because you might get some frames of a different bitrate. So you can only really guess what the bitrate is going to be. Maybe the average bitrate of the first 20 MP3 frames or something like that. So I'm going to reply and say MP3 files consist of MP3 frames, each of which has its own bitrate in a constant bitrate file, brackets CBR. All frames have the same bitrate, but you can also get variable bitrate MP3s, VBR. If you have the whole file, you can calculate the bitrate by dividing the number of bytes by the total number of seconds, and MP3 file reader can give you that information, can give you the duration, I should say. And in fact, if I bring up the code, MP3 file reader has an MP3 wave format property, and does that have a bitrate in it? Let's have a look. It does have an average bytes per second, from which you can calculate the bitrate by multiplying by 8. So let's point this person in the direction of that. I don't know if they're using MP3 file reader. MP3 file reader also has a, what should we call it? What was it called again? MP3 wave format property, which contains average bytes per second. If you multiply that by 8, you get average bits per second, and divide by 1000 to get kilobits per second. I'm assuming it's divided by 1000 and not 1024. I'm never 100% sure in which situations things are done in thousands or 1024s. I know with gigabyte disks that doesn't mean 1024 by 1024 by 1024. It just means 1 times 10 to the 9 bytes. But that will get them at least in the right ballpark of what the bit rate is. So I'm going to reply to that, and if you managed to watch all the way to the end of that, well done and thank you. It does seem that there's one person watching live. I hope that the video quality and the audio quality was a lot better than the last video, but if not, I'll try again on the next one, because there is a never-ending source of these NAudio questions coming into my inbox every day, and I do try to keep on top of them, although I do sometimes get behind. I deleted about 100 questions from 2014 the other day that I've just had to accept I'm never going to get round to answering. But thanks for watching, and I look forward to seeing you on the next NAudio live stream.